All right, welcome back. Let's take a look at Chapter 1 and 2, Quarterly Based Standards Test, the second side. First thing we're going to do is find the absolute value of 6x minus 9 when it equals 33x. 6x minus 9 equals 33x, and also 6x minus 9 equals negative 33x. The big difference here is when I go to break this absolute value symbol and just scoop out 6x minus 9, when that happens, remember that I'm going to have a positive and a negative solution side to start. So when I solve these out, I may have two answers, I may have one answer, I may have zero answers. We're just going to have to figure it out. At the end of the day, this, whatever's on this side, whatever comes out of it, because the only thing that's on this side is an absolute value symbol, it needs to be positive. So 33x, whatever that number for x is, it needs to be positive, because the only thing that can come out of this absolute value will be a positive at this point. There's no, coefficient at the front, there's no numbers at the back. It's literally just an absolute value symbol. When you solve it, it will need to be positive. It has to equal a positive integers. So let's look over here to figure this out. We're going to subtract 6 from both sides. All right. Now we'll divide through. Okay, so 9 over 27 will reduce down to negative 1/3, and negative 9 over 39 will reduce down to positive 3 over 13. And we need to make some decisions about which solutions we're going to accept and which solutions we're going to reject. Remember that everything that comes from this answer at this point will have to be positive, because the only thing we have on this side is absolute values. So this 33x will have to be positive. If I multiply 33x times a negative number, this will turn negative. And that is an impossible situation, because that violates the definition of absolute value here. So it cannot be the negative solution. The only one that we can accept should be 3 over 13 equals x. When we look at our answer options, that's going to be answer option C for us. Okay. The next question here, number 7, asks us for the absolute value of the difference of half a number and 11. They tell us that it is equal to 6. Which values of x will satisfy the statement? We can do this two ways. We can just substitute in all of these numbers, or we can solve this out algebraically. So I can say that half x minus 11 equals positive 6, and half x minus 11 equals negative 6. All right, I can add 11. And I'm going to get half x equals 17. And I'm going to get half x equals 5. Okay. So from here, let's take a quick thought as to how we're gonna finish this. To get rid of this 1/2 x, I can multiply by 2 over 1. A fast way to think about that is when you multiply 2 times 1, you get 2. And when you multiply 1 times 2, you get 2. So this is just 2 over 2 when you multiply it together. And 2 divided by 2 is just 1. So that will cancel out to 1. And I'm just left with this 1x here. Now if I do it to one side, I'd have to do it to the other. So I need to multiply this side by 2 over 1 as well. 17 times 2 is 34. And I can do the exact same logic on this side. I'm going to multiply by the reciprocal of 1/2. The reciprocal of 1/2 is 2. 2 times 1 is 2. 1 times 2 is 2. and 2 divided by 2 is just fancy 1. So this is 1x. And if I multiply one side by 2, I need to multiply the other side by 2. 5 times 2 is 10. Both of these answers are looking good for me. This over here is truly a situation. It's a positive 6, so if I have a absolute value, it will have to be positive. All of this checks out. These are both the correct answers. So 34 and 10 need to show up in my final answer. And there they are with option G, 34 and 10. Okay. The graph now shows the value of a baseball card over a period of 9 years. So here's time 0, and then here's over a period of 9 years. We do a quick slope here. Your rise, you go from 6 all the way up here to 12. The difference between 6 and 12 is 6. And then here, they told us that it was 9 years. So we know that we go from 0 all the way out to 9. Rise is 6. Run is 9. 6 divided by 9 reduces down to 2/3. And now let's talk about variables. The 6 is related to the y-axis. And the y-axis is all about dollars. So this represents $2. The 9 is all about the x-axis, and the x-axis is all about time. So this is 3 years. So you make $2 every 3 years. And when you read your answer options, they give you $3 every 2 years or $2 every 3 years. And we're going to take the one that says $2 every 3 years. And that's how we do rise over run. So number 8, answer D. Number 9. It says you have a graph here, 3 times the absolute value of x minus c. And one point of it is 0, 12. So which point can't be on the graph? A couple of different ways you can think about this, but the first thing I'm going to do is think about solving this out right here for c, to make sure that y equals 12 when x equals 0. Okay. So let's make that happen. Let's look at number 9. And we've got 3 times the absolute value of x minus c is y. Our coordinate point was 0, 12. All right, so we know 3 times x was 0, so we don't need to write that, minus c is good, and then equals 12. We're going to divide through by 3. So we have 0 minus c equals 4. 0 minus anything, we just take the 0 off, and now we have negative c, or opposite c. So what could go in here? Well, we could put a positive 4 in here. If we put a positive 4 in here, and then we make it negative, when we solve the absolute value, it will turn out positive 4, and positive 4 equals 4. So that makes sense. That's true. We could also put in a negative 4, because a negative and a negative would be a positive, and the absolute value of positive 4 is just positive 4. So 4 equals 4, and that also works. So we have 2 solutions here, positive 4 and negative 4 for C. So let's do 3 times x minus 4 equals 4. And let's see which of our answer options works out for us. If we put in a negative 4, let's see if our model works for us here.